Today we'll be talking about a developmental network that can lead to the production of spikes in the skin cells of thorny dragons. So we see S leads to P, which inhibits I, which inhibits K, which makes E, which leads to spikes. So in our wild type, we'll see that S leads to P, which inhibits I. Without I, K is not inhibited, which means we do get E, and if we get to E, we make spikes. All right, so that looks like this. Burn down to S, we would hit I and be inhibited, but P circumvents. We burn K, we burn E, hit our firecracker, it explodes and gives us spikes. All right, so what about P not being present? So we get S, there is no P, which means I is not inhibited, which means I will inhibit K. K will not produce E, and we get no spikes. So that looks like this. We burn down to S, we hit I, we're inhibited, we cannot burn the rest of the way, blow up the firecracker and make spikes. So what about if just I were missing? Well, S would lead to production of P, so we have P. P would inhibit I, but I is not even there, so it doesn't matter. Without I, K can produce E, E can produce spikes. So that will look like this. S leads down to P, leads down to K, K will burn E, E will burn the firecracker, blow up, and make spikes. Now what if I and E were missing? We know what happens if I is missing, it makes spikes, but without E in this situation, we get no spike production. So it looks like this. We have everything we need, except no E. Without E, we cannot burn the firecracker to blow it up and make spikes. So what if just S and K were missing? Well, as we move down, we have no S, which means no P, which means I is not inhibited, but there is no K, so I has nothing to even inhibit anyways. Without K, there is no E, and with no E, no spikes. So that looks like this. We have I, we have P, we have E, but there's no K, so we can't burn E to burn the firecracker, blow it up, and make spikes. All right, so a regulatory pathway for this could be sunlight exposure causing acetylation, right, in the cells of the backs of thorny dragons. So the backs are exposed to sunlight, causes acetylation. Acetylation will upregulate the transcription of our spike gene. Stomach cells have no sunlight exposure, so they wouldn't get acetylated, and they would not have an upregulation of our spike gene. So think of this, boom, lighter, sunlight, back cells, lights the fuse, leads to production of spikes. No lighter, no sunlight. The odds of this spontaneously combusting are extremely low, so we probably won't blow this up and make spikes.